Okay, for number 7, okay, we have a given polynomial function, and we have 3 parts here, and the first of which we have to determine the leading coefficient a of n. Okay, so we have, first of all, okay, we have with this polynomial function, we have expressed in factored form, and let's say that in terms of how the behavior of the graph of this function is going to be, especially around the zeros as well as the end behavior. Okay, we can look for what is going to be the highest degree term and okay, so we have with the highest degree term. If you look at the factors, okay, first of all we have -6 as the first factor, which we have to be a standalone coefficient. And then we have for the next factor, okay, we have between 2x and -4, 2x is the higher order term, and it's going to be taking that portion and cubing out. As for 2 minus 6x quantity squared, okay, higher degree term, we have between the terms in the binomial, we're going to have it -6x. And that is going to be squared, and we have with x plus 5, x is the higher order term. And looking at what we have in multiplying, okay, so you got -6. And if I were to have 2x minus 4 times itself, the highest degree term in the product would end up becoming 8x cubed. And if I took the square of 2 minus 6x, like 2 minus 6x times 2 minus 6x, highest degree term would be 36x squared. And of course from x plus 5, okay, again we have x. And if I multiply all the terms out, okay, we have -6 times 8 times 36. And we're going to have most negative value, which will be -1728. And for the powers of x, you have x cubed times x squared is x to the 5th, multiplied by x, so we have x to the 6th. Okay, so we have for the leading coefficient, okay, so we have a of n. Okay, that is going to be at -1728. And now for what we have in terms of the end behavior, again, just on the back of what we have here, so you have a of n, we have at -1728. So you have the leading coefficient is going to be negative, and the degree of the overall function, again, this coming from the highest degree term, so you have n is equal to 6. So you have even, and again, if you have your leading coefficient to be negative and the degree of the function to be even, okay, what is going to happen here is that for the end behavior, right, whenever you have even powered functions, they'll be the same at both ends, either going up or going down. And since we have negative, we have moving down to the left or down to the right, or like in Alex's terminology, falls to the left and falls to the right. Okay, so you have down to the left and down to the right. Okay. And in terms of graphing, what we have for f of x, all right. So we have here taking what we have for the x factors. Okay, so looking for the zeros and the multiplicities. Okay, -6 is just a constant. Now for 2x minus 4, okay, if I were to set this to 0, I would have that x is equal to 2. And since 2 originates from 2x minus 4, which is raised to the 3rd, okay, the multiplicity is going to be at 3. For 2 minus 6x, if I were to set 2 minus 6x equal to 0, I will have a fraction for x, which would be at 1/3. And the multiplicity of x equal to 1/3, since 1/3 originates from 2 minus 6x, which is raised to the 2nd. Okay, this 0 has a multiplicity of 2. Now for x plus 5, we had that x is equal to 5. And since we don't have any explicitly raised power for x plus 5. You read this as if it were x plus 5 raised to the first. So the multiplicity of 5, okay, is going to be at 1. And, okay, so we have for crossing or touching the x-axis. And what's going to happen here again for zeros of odd multiplicity. Now the graph is going to cross, and for zeros of even multiplicity, we're going to have to touch. So here we have multiplicity be odd. Okay, so we have to cross the x-axis at x equal to 2. And since 1/3 has a multiplicity of 2, again we have an even valued multiplicity. So this one you're going to have to end up touching at x equal to 1/3. And for x equal to 5, you have a multiplicity value of 1, which is odd. So that one is going to cross at x equal to 5. Okay. Now, for what we have in terms of the end behavior, x and the y axis put up. Okay, so okay, so just taking what we have and somewhat labeling. Okay, so you have our zeros at 1/3. You also have x equal to 2. And we have x equal to 5. And again, just for the end behavior, you had down to the left and down to the right. Okay, so I'm moving down to the left in behavior and down to the right. And if we look at reading the activity in order from left to right, okay, so as we get to x equal to 1/3. Now the graph is going to touch. So we're starting out below the x-axis, and as we get to x equal to 1/3, okay, now the graph is going to touch and it's going to fall below. However, as we get to x is equal to 2, okay, it says that the graph is going to cross at x equal to 2. So we're going from below to above the x-axis, and as we get to crossing over to the threshold at x equal to 5, the graph again is going to cross the x-axis at x is equal to 5, and we have going from above the x-axis to below. So we have for the rest of the activity, we have moving downward. Okay, all right, and so that would be the result of what we have in the case of number 7.